Right, cool. Let's start. Hey, Suyash.
Hey, Andre.
Thanks for my time during the call today. And yeah, with me today is Singh, the co-founder of GalaxEye, the satellites constellation company based in India. And today we're going to talk about the business of GalaxEye and what makes GalaxEye stand out of the competition with their approach towards building the constellation of satellites. So, Suyash, tell me a bit what GalaxEye is and how did you come up with the idea together with your team?
Sure, Andre. So first of all, thank you for having me here. It's an opportunity to talk about GalaxEye, and I love this. So yeah, GalaxEye is one of the early stage companies based in India. We are based in down south in Chennai. Down south in India in Chennai. We're primarily into building satellites. Now, the satellite is a lot of people are trying to do satellites, but what we are trying to do different is we've come up with a very different sensor called district sensor system. Now, this T sensor system is nothing but, it's a hybrid sensor which combines multiple properties of different Earth observation sensing mechanisms and, give out the best data product. So the overall idea is to really come up with a, data product which will be utilized by the end user to solve use cases from utilities, oil and gas, to defense, to finance, to insurance, to a lot of other domains. So we kind of figured out that the gap is not really in building a scientific data set, but the gap is really to how to take the satellite imagery and make it commoditized by people, who are actually into artificial intelligence and machine learning, right? So, for example, you want to count the number of cars. You can probably take an optical or a multispectral imagery
Mm-hmm.
from a service provider, and you can count the number of cars. But when it is cloudy, then the other option is you go to radars, right? And then you try to do you try to build some algorithm on top of radar imagery and do it. But the point is, one or the other way, there's some or the other data which is missing. Right? So come up with the complementary data set. Right? We have come up with this idea, which is basically a hybrid sensor mechanism which fuses multiple sensor data into one, right? And that is eventually something which is well suited for all the AI and DL applications, right? And thus it makes us a little more differentiated in the Earth observation market.
So like your biggest innovation is the actual integrated hybrid sensor, right?
Right, absolutely.
So the way I got it, and correct me if I'm wrong, it's if I smash together the Planet Superdove and the Capella satellite together and like fuse them together and make like one unified sensor, that's the Drifter sensor, right?
In a way, yes, but it's not that straightforward.
And how does it look like? So how the data sets is different from what you can expect from like other, let's say, radar constellations versus the optical constellation. So how the data sets of the fused like hybrid sensor looks like and compared to the like single sources of the data, and like what should data scientists should be excited about this data set?
All right. So I think the data set is very similar, right? But like for example, we are not here to come up with an extremely complex mechanism for data scientists to really load the data, then
Mm-hmm.
clean the data, and then ingest it. The overall idea is to keep the standard same, right? But add a layer of fusion on top of it. For example, a data scientist will benefit from this because now he gets more availability, because with optical, there were clouds all the time, so he was bothered about availability. Every 7 days or 5 to 7 days he'll get a good picture, and that too in some continents it is not possible to get a good
Mm-hmm.
good shot from optical. So the overall thought process here is not to play with the standards. The standards of image will remain same, but what will change is the additional layer of availability, the additional layer of metadata information, that will combine radars, like something that is missing in radar and something that is missing in optic, that comes through that kind of metadata layer.
And from what I know about the company, I understand that making this engineering decision to go with this type of hybrid sensor should pose a lot of challenges on how you develop the whole like architecture of the bus and the payload accommodation. So can you talk a bit about what this architecture looks like and what engineering decisions you had to make with your team in order to accommodate such I would say a complex or a new model for the hybrid sensor?
We are trying to keep the satellite small. At the same time, we are trying to serve all the customers that we have, right? So our strategy is not to really map anything and everything. For example, we don't want to map oceans unless we have a customer from there, right? But we'll map very specific areas which our customers would want on a regular basis, right? So thus we kind of save on energy. We are trying to make a trade-off between the demand and what the operations that we can do, so that we still are in the microsatellite class of satellite, and we're not trying to map everything.
Mm-hmm. Kind of makes sense. And you touch base a little bit about the customers, and I know it's hard to win the commercial contracts without the actual satellites in orbit, but I assume you do have some traction. So how does the customer traction or your, I would say, service or market or the market you target first, how they look like?
It's very evident in this industry that customers are always hunting for a new data set, right? Because their problems are not solved. So what we have seen so far is anything and everything that is available is limited in a way, right? Either in the terms of availability or the kind of richness in the data set. So customers are willing to wait for some time to really get the data. It's unlike in the SaaS companies that customers when they engage with someone, they start getting some sort of service in a freebie manner or in some other fashion. But here, customers appreciate that it takes some time to build a satellite, and they are willing to spend some of their time with us to help us understanding what are their pain points and what exactly they would like to see in a short while. For us, we have been fortunate in that way that we've got few customers who who are from the geospatial world, and they're really interested in talking to us, and they really find a good value in what we're trying to do.
Mm-hmm. And are those domestic customers in India or are those international ones?
I mean, it's a mix of both. We have Indian customers as well. We have from Europe as well as in the US.
And talk to me a little bit about the ecosystem in India. So, like as we talked earlier, I've been to India a couple of times pre-pandemic, of course, and I was amazed by the amount of really, really good senior engineers coming from both the startup world and the international competitions. Do you have, especially with the recent changes in legislation in the country, do you have any support or at least lack of obstacles from the government in India, and how does that play a role in the early days of the company?
Yeah, I think we are sitting in one of the best ecosystems in the world. The reason are two. One is India is a spacefaring country, right? So there are a lot of expensive labs which are there at ISRO's facility. Even though if we are not allowed to access the ISRO facility sometimes, then there are a lot of supply chain, which is already established in India, who have actually supplied components to ISRO for like last 30 years. Mm-hmm. So supply chain is extremely robust. However, the opportunity here is to really, convert those components from bigger satellites to small satellites. Right, so because they have been doing all the component engineering for ISRO's massive satellites, now they have to scale it down so that they can fit it with CubeSats and microsats. But I think that is something that people are taking up very nicely here in India. Apart from that, the government support is huge. Indian government is looking at privatization of space tech a lot higher than last 2 years before, and there has been, a wave of space tech startups also coming up in India, right? So the ecosystem is quite rich in that fashion, I would say.
It's good to hear. And like the good indicator for how robust is existing supply chain in India is like the ratio of local suppliers, local components that you use in your mission versus the ones that you rely on international partners. So can you perhaps just say a few words about, like what were you able to source in-house, like, domestically, and what like key components or key services you need to rely on international partners?
I think it's quite widespread, right? Yeah, yeah. Anything and everything is available outside as well as in India. The only thing is, at this point of time, the micro satellite engineering or component availability is slightly lesser, in India, and thus we look for other global players to really come and whose specifications can meet our requirements will kind of go with them in some cases. So, for example, right, reaction wheels is slightly a component which is not available in India in large numbers. So we need to kind of outsource that, bring it from other countries. But I would say space is beyond boundaries, and there's nothing like that. There's nothing or something which stops us to really communicate through other partners sitting in anywhere in any part of the world to communicate.
Yeah, I wish your words about space being beyond the border stays true, because like, with every year, I just tend to stop believing in that. But yeah, as long as there's International Space Station, I guess we're still there, like on the communication beyond the borders. But yeah, I wish it could stay longer. Yeah, so can you talk to me a bit about how far you are in both, like, the company journey and also in the development of your first mission?
Yeah, I think we would love, or we would love to do everything in next month, but of course things take time. So the plan is to really launch the first satellite by the end of next year, and so in terms of how rocket says, we are t minus 21 months away. So that's where we are. In terms of development, so I talked about the lab scale testing that we did about from our sensors. So we are doing multiple iterations on that. Right? We have written few algorithms on top of it to really make the data run and give some insights for particular use cases. So there has been system design and everything has been done. We are almost on the verge of kind of procuring the components, assembling it, and then sending it to space. So
That's great. I understand, because we're talking about microsatellites, not even the CubeSats, and of course developing new sensors. So it's not like just integration of the off-the-shelf components from which are available in market. There's a lot of R&D and associated risk with that. I wonder, how did you overcome the funding challenge? So how difficult or how easy was it to secure the funding, and what is the primary source of funding for you guys?
we come from a deep tech project. We did Avishkar Hyperloop before doing GalaxEye. So we our team basically was one of the only Asian team, in fact, the only Asian team to reach SpaceX Hyperloop pod competition in 2019, and we finished in top 10 there. That gave us a lot of confidence in building hardwares, right? And because we are sitting in one of the most prestigious institute of the country, the grants and everything are slightly available to us. So we started off with few grants to do the R&D at a very small scale, but then we wanted to accelerate a little faster. So we have raised one round of funding from an investor in Bangalore in India, and that's what is keeping us going and developing a bigger sensor module and test, and of course to expand the team. So yeah, I mean we have one round of funding from a VC, and in fact, I can, I mean it is undisclosed as of now, but we are raising another round, which I mean probably in a couple of months, which will help us to go to the satellite as well.
That's great. Yeah, and how big is the team now?
We have around 15 engineers who are full time. Then there are 20 interns, who come in and go out.
Amazing. I ran out of questions. Thank you so much.
Thanks, Andre. Nice talking to you.
Yeah, thanks, Sush, and I wish you all the luck and all the best with your not only first mission but your overall journey as a company. And yeah, looking forward to working together with you guys.
Same here. Thank you. Thank you so much.